Kia ora Year 12 and Year 13. This is a question that Chestnut from Onslow College emailed me in, and it's a nice related rates problem. So here's the question. It's from a revision book, but I've changed it around because of copyright things. So it's about a kitchen timer, and the kitchen timer is in the shape of an upside down cone. And liquid flows out of the top part of the timer into a bucket underneath it through a little hole in the bottom of the cone. And it takes an hour to empty into the bucket. And at the start, when it's full, the radius of the cone is 9 centimetres and the height is 30. And the water is flowing through to the bucket at a constant rate. So what we have to find is how fast is the water level dropping 20 minutes after the timer starts. So let's start by drawing the cone. So there's the cone in 3 dimensions. There's the little hole, and here's the very ugly bucket. So the water starts off in here and it drips through. What we need is to draw that cone in 2 dimensions and to also write down the formula for the volume of a cone. Oops, wrong pen. V is equal to 1/3 pi r squared h. Okay, so we know that at t equals 60, V is equal to 0. Right, at t equals 0, what's V? Well, V will be 1/3 pi times the radius squared, so 9 squared, times 30. Right, so let's figure that out now. My starting volume is 10 times 81, so 810 pi centimetres cubed. Right, let's go back to the question because we can now figure out what dV by dt is because we're not told it, and we usually are. Right, let's see what it says. The water flows through to the bucket at a constant rate. So we know the starting value is this, and we know that after 60 minutes, it's this. So we can work out the rate of change. It drops by 810 pi per 60 minutes. Now, what does that give me? Well, that gives me dV by dt is equal to negative 13.5 pi centimetres cubed per minute. So that's useful. Right, now let's look at what we're trying to find. We want to get dH by dt. And we know that V is equal to 1/3 pi r squared h. There are 2 ways to do this. We can do this one as a 3-way chain rule thing. So we could do this dH by dr times dr by dV times dV by dt. But in this case, I found it pretty straightforward to do it as just a double chain rule, so with 2 bits. So we're going to find dH by dV times dV by dt. Now we've got that already. That's my negative 13.5. So the next thing we have to work on, as usual, is the link between height and volume in the formula. At the moment, we've got r squared in here. So we have to eliminate r squared somehow. So we go back to the question. We're told that the cone, when it's full, has got a height of 30 and an r of 9. So this is going to be a similar triangles question to help me link the r and the h. So there's the big triangle. And now here's my baby similar triangle. Now we know they're similar triangles because we know we've got a right angle there. We know we've got the same angle at the bottom. So this angle has to be here, has to be the same as this angle here. So because we've got similar triangles, we can say that 9 over 30 is equal to r over h. That tells me that r is equal to 9h over 30, or simplifying, r is 3/10 of h. Now look back to our formula. We've got volume with r squared and h in it. I want to eliminate r, so I'll square both sides. And get 9 over 100 h squared. Right, I'm going to take this and I'm going to substitute it in here. giving me V equals 1/3 pi times 9/100 h squared times h, which simplifies to 3/100 pi h cubed. So the problem just got a whole lot easier. Remember, we're trying to get dH by dt is equal to dH by dV times dV by dt. And we figured that one out at the start. So we're working on this bit. Let's differentiate V with respect to H. Now, dH by dV is the reciprocal of that. So it's going to have 100 over 9 pi h squared. We're just about there. We've got dH by dt will be this, and dV by dt was negative 13.5. Simplifying, I get negative 1, oh, I've missed a pi there, I think. Have I? Let me just check back. What was my rate of change? Yep, so there, that was nearly a bad mistake, right? So dV by dt's got a pi in it. So scrolling back down, now we have no pi left. So negative 150 over h squared. Now I've done this with my unit of time as minutes. It'll work just fine if you do it with hours, so it won't matter at all. So now we've got to here, but then we say, well, hang on, what's h? Well, the question asked us to figure out the rate of change in the water level 20 minutes after the timer starts. And we know that it takes an hour to go the whole way through. So the easiest way to do this is to go back to year 1 and draw your number line. Here's t equals 0, and here's t equals 60. This is what we want, which is t equals 20. So at t equals 0, volume is equal to 810 pi. And down here, volume is equal to 0. So this is simple proportional reasoning. Volume's dropping at a constant rate. So what's the volume after 20 minutes? Well, the volume will be 2/3 of the volume when it's full. So volume is equal to 540 pi. And we now have to solve this to get the height. Right? So our volume equation was 3/100 pi h cubed. Right, that's from up above, and that's after we'd got rid of the r. So solving that, I get 540 times 100 over 3 equals h cubed. H cubed is 18,000 cubic centimetres. So go and grab the cube root of that. We get h is equal to 26.2 centimetres. Right, it is an excellence question, and it's quite an involved one, but it's really good practice for related rates. So that gives me dH by dt is equal to, here's the very last bit, many bits of paper. Shove that in and we get, oh, where's it gone? Sorry guys, too many bits of paper. Negative 150 over h squared. Right, now that gives me negative 0.2184 centimetres per minute. If you were working in hours, if you times by 60, you'll get the hourly rate, which is negative 13.1 centimetres per hour. Okay, leave me a comment if you've got questions on that. Sorry, this was quite long, but hopefully that helps. Remember, related rates problems come up often, and they come down to simple trig, similar triangles, or Pythagoras.